Hello and welcome to Facebook Live. Today it is National Science Week, and we are here to talk about science and engineering, and we're in Defence Science and Technology Group here in Melbourne. And what we're going to do today is we're going to do a bunch of different tests and practical things, a bit like Mythbusters if you like, and we're going to talk about Armour and Armour systems and how that can work and help keep our Defence Force personnel safe. But we also need science experts, and with us we have a couple of science and engineering experts. We have Brian from the Australian Army. Tell us a bit about yourself, Brian.
So, Major Brian Merton, I am a mechanical engineer in the Army, and I currently work for Defence Force Recruiting. So I work for the Specialist Recruiting Team. So we're looking for those high school students who have a passion for engineering and want to study at the Australian Defence Force Academy, or people who have already found that passion and started studying at university and we're looking to join by the Defence University sponsorship, or people who have worked in industry for a couple of years and want to bring those skills to the organisation and apply them to more defence-specific equipment and processes as well. But in my former role as a mechanical engineer at Headquarters 1st Division, we worked in support of operational preparedness, so training forces for operations, but also assisting Headquarters Joint Operations Command to manage any risks that may arise in theatre. So providing that engineering advice and expertise to manage emerging threats for the occupants of equipment on the battlefield, or designing new systems to make the equipment safer for them. So always trying to make what we do safer, because there's sometimes that we can't remove all of the risks associated with military operations.
Thanks, and if you've got any questions, obviously we're live, this is a Q&A. If you've got any questions for Brian, send them through and we'll get to them over the course of this live broadcast. Hugh, this is your workplace?
It is, Nick. So my name's Hugh Bornstein and I work at the Defence Science and Technology Group, and my job is to be a blast protection scientist. So if you want to know what that is, basically I get to blow stuff up for a living, which is obviously all fun and games, but there is quite a serious purpose to that. And one of the things that we're just going to show on your screen now is a video of some testing that we've done on a Bushmaster that is being subjected to an explosive. So what you can see is this is quite a severe event, and what my job is to come up with protection systems and work with other members of the Defence Force and defence industry to come up with solutions to make sure that when these kind of incidents happen to soldiers, that they can walk away safely.
So, once again, if you've got some questions for Hugh, it's a Q&A, you can ask them through, and we'll get to them over the course. Right now we're going to cross to an experiment that we did earlier. So, once again, this is about Armour systems, and it was we'd love to blow things up. We would love to show you some explosions. Alas, we are in a science lab, so we can't do that. So we've done a bit of a simulation. So check this out, and there's a challenge for you to get involved as well in terms of picking what you think works best. So have a watch of this. Today, what we're going to try and do is show you a bit more about how Armour works. So we've set up a bit of an experiment, and we're going to get you guys to have a bit of a guess on what works best or what doesn't. So with us we have our experts again. So Hugh, how does this work? What have you got in your hands?
So what I've got here is a simple aluminium barbecue tray, but what we're going to use it for is to represent our hull of an armoured vehicle. And so what we've got down here is our mini representation of the armoured vehicle, and we've put our barbecue tray in as a hull. So what we've actually found in this case is if you can pass me over one of our projectiles, this is an example where we've got a new threat that we're trying to defeat against armoured vehicles. So we've got our little mass here, and that's going to come in from a particular height. So we're looking at what happens if this projectile was to land on the roof of a vehicle. And what we're going to go through is a range of different armour solutions that might work to give us better protection. And we want you to guess which option is going to be the best. So the most basic solution to armour is to just add more of it. So we've got a second aluminium barbecue tray, which we could put on like this. Another option might be to use some foam. So we've got some foam here, and we're going to do a test where we add this to our base armour system. A third option one that you may recognise from our for your knowledge of armoured vehicles is a V-shaped hull. So we're going to drop the projectile and see whether this V-shaped hull improves the performance of the armour system. And what we'd like you to tell us is which one you think will perform the best and why. And we'll get back to you with the results shortly.
So we're back, and hopefully you've come up with your own sort of hypotheses as to which armour system works. Not just barbecue trays; they have many other uses, as you can see. Have a guess. See which one you reckon is going to be going to work best, either the first, the second, or the third, and let us know in the comments. We'd love to sort of see. So obviously, science and engineering is a passion. That's what got you guys into it, I'm sure. Brian, what made you join the Defence Force, and what made you, I suppose, get a passion for engineering?
Probably all started in high school. So I always loved to solve problems, but also I loved to understand why things worked, how they worked. So I did choose those sciencey subjects, so the chemistry, physics, mathematics. It was also pretty creative, so a little bit of an outlier there was visual arts. But that actually came back to be a benefit to me a little bit later on in my career. But in year 12, I wasn't looking for a standard 9-to-5 job where I'd be doing the same thing every day. I wanted something that was going to challenge me mentally and physically. So I chose to join the Army as a general service officer, and I started my career at the Australian Defence Force Academy, which was probably one of the greatest experiences I had. And following on from that, an incredibly rewarding career, getting to go and study mechanical engineering at university and put those skills into practice to make the equipment in the workplace a safer environment. And now I currently work at recruiting, obviously looking for those future engineers to take up those leadership roles within the organisation, which is just as equally as rewarding. So mentoring and bringing that next generation of people to hopefully replace me within the organisation and bring their passion as well.
Brian, it wasn't just study at the start at ADFA for you, was it? There's been a continual study process?
Yeah, definitely. So I didn't really know I wanted to be an engineer when I joined. I actually studied science, double major in chemistry and physics. It wasn't until I got into my role as an electrical mechanical engineering officer, so a non-qualified person in the Corps, that I discovered what engineers could actually do and how they actually had a positive effect on people's lives. The great thing about defence is the opportunities that exist. So not only initial employment training, so my first one was to study at ADFA and then do my officer training at Duntroon, but also opportunities to go and upskill and provide more, I guess you could say, capability for the organisation. So I actually got posted back to study mechanical engineering. It was a great opportunity for me because it built on that science passion I had as a high school student and through engineering. But also allowed me to put those skills into practice and start solving some real world problems for people, which was really good fun.
Okay, so there's a lot of it. If you've got that passion for science and engineering, if you've got that practical sort of brain,
yep.
There's lots of different things you can do, and obviously we're at the pointy end of the science and engineering here in this area, but there's lots of other things you can do as well.
Yeah, definitely. I talk to a lot of school students in my job in recruiting. So they ask me, what should I study to get into this role or this role? And there are a lot of students who are in year 9, 10 and 11 who really don't know what they want to do when they graduate. They're not sure if tertiary education's for them or if they want to go and get a trade or go and work in a technical field, so potentially IT. The best advice I can give students who are going through high school, study the sciences. They're going to open up the most opportunities for you when you graduate from high school. They're going to be hard. They're going to challenge you mentally, but it's going to give you options when you graduate. It's really disappointing to see people who discover late in their life that they want to go and study engineering or they want to take up a trade, but miss those key competencies in the science, the physics and the mathematics that are really going to enable them to complete that study and move into a really rewarding career. So it's not just about engineering study at the university level. We also have opportunities for people to go and do trade training. But again, one of those base competencies is a component of science, whether it's at the year 10 level or at the year 12 level.
And Hewan, I think it's probably time to sort of start to talk a bit more about what's around us, and what better place to start than with this guy.
This guy over here.
We'll wheel him in. See if I can
what do you want to know about this guy, Nick?
Well, you know, he's he's dressed for the part, but I guess what is he and what does he do? What role does he perform?
So this guy, his name changes pretty regularly. It sort of depends on which of my managers I'm most frustrated with this current week. But in all seriousness, what he is a side impact dummy. So developed for car crash testing for side impact. And the difference between him and a normal frontal crash impact dummy is these ribs in here. And so what you find is there's a number of instrumented ribs that we can take measurements and look at how far they've moved and what kind of injuries we would get. But as well as the ribs, there's also about 35 other sensors on this particular crash test dummy. So we get an idea in all of our testing, like you saw on the Bushmaster before, what level of injury a person would be, which gives us all the information we need to understand whether our protection system that we've designed has been effective or not.
So this guy sits in the vehicles that you're testing, and to make sure that it's a simulator for so you're not using real people.
That's right. We would obviously never put a real person inside a vehicle when we're testing it. As much as, you know, as designers we think our technology is going to work, we're probably not going to take that risk, and so these guys take our place.
And it's not just this guy. This is obviously the big guy. We'll call him Buster or whatever your boss's name.
I won't mention that one for this week.
Yep. There's also this guy. He's called B1. I'll just put down the questions there for a bit. He's called B1, but I don't know whether B2 exists as well.
I think there was a B2. They had a falling out, so he's not with us today. But B1 is just a mannequin that we use. So in some of our blast events, we want to measure the pressure that a person would be subjected to from a shockwave, because that can cause injury to them. And so what we would do is up here in the forehead and in the ears, we would place pressure transducers so we can record the pressure that they received and then link that back to the level of injury they might have sustained.
Is there any reason why it's sort of at the ears? Are these the weak points of the head, or?
In terms of the ears, so generally the injury threshold for blast pressure is governed by rupture of your eardrums, and so that's why we would often record information at the ears.
Okay. So you've got any questions, guys? By all means, please ask them. Jodie's got one here for you. Who do we talk to about the prerequisites for ADFA courses?
So if you look on the Defence Jobs website, there is quite a lot of information about the Australian Defence Force Academy. And looking at the prerequisites, you can actually download what courses you'd need to study for different subjects such as arts, business, science or engineering. But generally for ADFA, if you wanted to study an engineering degree, or really any of the degrees at ADFA, your key competencies in physics and mathematics are going to be the most important for you. They are all assumed knowledge, but again, those key competencies you can build on for a variety of different degrees. So definitely Defence Jobs is the first point you look at, and then have a look at the ADFA prerequisite requirements.
And just to follow up, that was for Jodie Ann, but for Callum, what age can you apply for an ADFA? Of the science degree, you can apply at age 16, so a bit earlier, and you can, once you've got those prerequisites, start your application early, so you can focus on your studies in order to get in there. Now, what else have we got around us here, Hugh, as part of your science lab?
It's part of my setup. So this particular example is not from my area, but we also, as well as working on vehicle protection at DST Group, we also do a lot of work on personnel protection. So this particular head form is used for ballistic testing of helmets to try and make sure we have our helmets designed to protect our soldiers when they need that.
Okay, and we've also got a few other things. So this feels heavy. What is it?
So this particular one is what's called a frangible leg. So it's a simulant for your lower leg. They were actually developed here at DST Group, or it was DST Group in Adelaide, in conjunction with the University of Adelaide. And so what was done was they did a CT scan of a person's leg, and then they came up with a method of simulating that with a particular material for the bones, and then that's surrounded in ballistic gelatin, which you may have seen on programs like Mythbusters.
So obviously it feels heavy, feels like a leg. Like you can see all the bones and stuff in there as well. When you did your testing, you would have this all dressed up?
That's correct. So what we would do, similar to what we can see here with our crash test dummy, we would have put the military boots on top of that leg. So we make sure we're getting the correct loading into the leg.
Okay. And so what's the outcome of the test? So I can see you've got a couple of others over there.
So in terms of the main project that I've been working on over the last couple of years to try and improve protection of vehicles, the biggest thing I've been looking at is using water for blast protection. And the idea is that our armoured vehicles carry water on board already, and could we redeploy this to add to our protection system? Which is a really great example because it's basically free armour. Normally to improve protection we need to add something. In this case we're just using what we already have. So in this particular test we went down to Bunnings, we've got our jerry can here, and we strapped that on the outside of the armour. And so what we did was we used those frangible legs that you see before in our tests. So the first leg that I'm going to show you is the test from our baseline. So we didn't use any water at all in this particular test, and we deliberately overmatched the vehicle. So we made it a very severe test just to give this particular example. And so what you can see here is the severe damage to the leg, and this person would most likely not have survived the event. So you can sort of see significant damage, probably traumatic amputation.
Yeah, that's not really...
That's not very nice. So what we then did was we did our test with this particular jerry can of water, and so we now have a new leg, and this particular leg is still damaged, so the person would have still been injured, but they would have recovered from those lower leg injuries. And so this is a case of something essentially free armour, simple solution, jerry can of water, where some of the research we've done has the potential to go from life-threatening injuries to recoverable injuries.
So what you got there is science and engineering at work, and I guess the simple water jerry and the way that you deploy that water jerry and use of water is able to make the equipment safer and reduce the risk, which is, I suppose, what we're doing. And you've seen that before, Brian, in terms of some of the activities that you've worked on as well.
Yeah, so obviously engineering is always about learning new things, and we're always learning things on operations, and how we use our equipment changes, the threat environment we're operating in always changes. So we want to take every opportunity to analyse those incidents where we may damage some equipment on operations, look at how it was affected by the forces and potentially a blast, and then bring that information back. So working with DST, Capability and Acquisition Sustainment Group, to come up with new solutions to counteract those events and make the systems safer as well. So it's always about learning, and it's very much an iterative process. And every time we learn something new, we always want to integrate that into our equipment where possible. So we're making sure that incrementally we're improving the safety for troops on operations.
Some questions rolling in. By the way, if you've got any questions at all for Hugh or Brian, let us know. That's what we're here for. So Andrew Peters asked, what are some of the daily tasks for an electrical mechanical engineer fresh out of RMC?
So those first couple of years for an electrical mechanical engineer straight out of RMC is mostly in the maintenance management role. So it's commanding a troop of tradesmen. It could be at a regimental level, or it could be at a combat service support battalion, but it's setting those priorities and commanding those troops. So we're doing that hands-on work. Depending if you're an engineer, so a graduate from an engineering degree, or if you're a non-qualified officer in that role, is all about setting those priorities, looking at the operational environment and determining what your rate of effort is going to be. But it's also about managing your people as well, and making sure that they're progressing through their career and developing in their career as well. I know in my career, no 2 days have ever been the same, which has been exciting. It's always about the different situations that come up, the new challenges you have to overcome, and working with the great people as well around you.
So, and I guess that's the point. You haven't done just one job in your career. It's always moved from one thing to another thing.
Yeah, definitely. It's all about building on your previous experience, gaining new skills, giving something back to the workplace as well. I know obviously I started as a non-qualified engineer, electrical mechanical engineering officer, went back, obviously picked up a new qualification, put those into practice. So it's all about developing your skills, getting more responsibility, taking on more complex tasks, which is the exciting thing. You're not going to be stagnant in that one job for an indefinite period of time. The organisation is looking to train you more so you can provide more capability.
Okay. And obviously you're talking about the degree qualified engineering sort of pathway, and you did it through ADFA.
Yep.
There's some other ways that you can get, I suppose, you can get scholarships along the way.
Yeah, so probably the other one, if you want to study an engineering degree, Defence University sponsorship is another way that we can recruit some of those bespoke engineering degrees we can't teach at ADFA. So we'll go and look for undergraduates who are studying at university but want that exciting role within the Australian Defence Force as well. So similar to ADFA, you're sponsored through university, we cover your tuition fees. Most importantly, you've got a guaranteed job when you graduate, particularly in the tight labour market for engineers. And I think I said it before earlier, if you're a graduate engineer and you're looking for a career change, you're looking for a little bit more of a challenge, we also recruit graduate engineers as well, which is a great opportunity to bring experience from industry into the Defence Force and deliver some better capabilities as well.
And I'm not sure whether we talked about it before, Hugh, and when we were talking about your water jerrys and so forth, you know, you're doing that as part of your PhD.
That's correct, Nick. Yeah, so as well as working here, I've been lucky enough to be able to undertake some further study, and so that's a PhD while I'm also doing my full-time job. But you know, we're getting through it. And the real focus of that PhD is, I mentioned the water container protection that we used before. So that all started out as a kind of an operational type scenario where we were quickly trying to, you know, come up with a protection solution. The thing was, we didn't really understand how it worked. We just knew it did at the start. And so the role of my PhD has been really looking at how do we understand the physics behind why the water works, and then how can we take... Maybe seeing on your screens a movie that shows some numerical simulations that have been performed in our group. So looking at some of the really in-depth science as to why the water containers work and mitigate the loading from the explosive, and then we start looking at how we can optimize the design of our protection. And so we can start looking at more complex kind of shapes like this to try and get the best protection possible.
So from the Bunnings to this, I suppose there's no limit to how you can shape water in a container.
That's correct. So we can just come up with any kind of shape mould we like. Obviously we would speak to people like Brian in the services to make sure that we integrate the containers into the vehicle so that they meet the Defence Force's needs for functionality as well as the protection that they provide.
Okay. So you guys obviously who have tuned in may have seen the test that we did before. We just going back to, we had three options. We had the barbecue trays, so we had the foam, we had the double tray, and we also had the V-shaped hull. I think it's time to go back and actually have a look at those things and see what happened. So we'll throw to that and then come back with more questions. All right, it's experiment time. So what we're going to start with is our baseline test. Is that right?
That's correct.
So we're just going to use the single barbecue tray in our simulated armoured vehicle, and we're going to drop it from a height of
1.5 metres. So I've got my trusty tape measure, and we're going to see if we can line this up. It's very important with experiments to be consistent between tests. So 1.85. So yeah, about there. And so Nick, if we can help me, if we can help align the arm with the right spot. Maybe just back a little bit. And bombs away.
whoa, ooh, that's looking a bit grim.
So as you can see, pretty severe damage for the baseline case. Our bombardier may have been a little bit off centre on this particular case, but we've got plenty of damage to see if we can improve with our protection system. So the next thing we're going to do is we're going to test out one of our armor systems. So the first one was option 1, which is going to be the foam. So
yep.
Nick, you'd like to...
Just a couple of pieces of foam from probably Bunnings or maybe someone's seat, who knows.
That's it. So pretty simple, but obviously, you know, people have used foam to protect different things in societies. We'll see if it how it performs in terms of this application. So we've got a tape measure again.
I'll let you. You're the scientist. Do the measurement.
So we'll see if we can get some consistency again with the experiment.
Hit the target.
So we line that one up.
Yep.
So in position, just check so we get the square.
A little bit more towards
back,
you. Yep.
And bombs away. So we can see that the projectile bounced off the foam, which looks like it's done a pretty good job of protecting. And what you can see is quite a lot less deformation in this particular case. So it looks like the foams perform pretty well. So the next experiment we're going to do is option 2, and that's going to be the double barbecue tray. So we'll need a second tray going in.
So this is just the simple notion that 1 is good, 2 is better.
That's right. So we're obviously adding quite a bit of extra weight here, but it may, the aluminium may provide the best protection given the foam, so we'll have to see that. So we're at the right height now. I think just back a little bit. And bombs away.
It's dented the first one, but whether it's gone all the way through... No, it's gone all the way through.
Okay. And our final experiment is going to be our V-shaped hull.
It's gonna...
Out there. And bombs away.
Oh,
Not much at all.
Not much deflection at all there.
winner.
So we pop that one back in, we can take a measurement.
And so this essentially simulates what the V-shaped hull, which is on a lot of the more modern armoured vehicles.
That's correct. But in fact, the way it works in this particular case isn't necessarily the way it works for blast. So for blast protection, the idea is that the V-shape will deflect the blast away and reduce the amount of loading on the vehicle. In this case, that may happen if the projectile hits off-centre. It can deflect down the face, reducing the force. The way this V actually works in this particular application is that it transmits the loading from the centre of the aluminium barbecue tray out to the edges, which is a stiffer support structure. So it's a way of changing your load path in terms of your engineering design to give you better protection. So it's a slightly different theory to the way we use it in blast protection.
Okay. Results time. So here's the summary of the results. Here's our original, our first test. No armour system, just a single barbecue tray versus our projectile at 1.5 metres. And then we moved on to the foam, the 2 pieces of foam. And it deflected, did it? So I suppose...
Yeah, so if you have a look at the baseline, the damage is very localised to a single region. But once we put the foam in, we saw that a lot of the energy was dissipated across the whole area. So while it's still deformed, there was less localised damage, which was quite good. So it's reducing that risk to the occupants, which is important.
Yep. The third one was the dual barbecue tray, so twice as much material, which is twice as much weight, if we were obviously making this in real time. And it was still quite localised.
Yeah, so again, similar to the baseline, a lot of localised damage. So if the projectile was a little bit heavier or a larger load, we may have got penetration there on that armour. So whilst adding more was a potential option, probably not the optimal configuration for the occupants.
And the winner, with the least amount of deformation, was the V-shaped hull.
Which, if you look at it, there was very little deformity with the actual plate, which is good. So again, reducing the risk to the occupants, reducing the chance of penetration, and making the vehicle safer and getting closer to that optimum design where it's that trade-off between safety and weight.
Let us know if you've got any questions or you need some more answers around how these armour and armour systems work, but hopefully this is a good explanation and demonstration of how different aspects and materials can make things safer. So, science. Hopefully that was a practical demonstration, and hopefully you learned something about the different shapes and the complexities that really come into how Armour systems work. I'm like, this is your daily job, and you've worked at it for a long time. I'm like, it's layers, it's materials, it's all sorts of things.
That's right. So a lot of people think of blast protection as being synonymous with the V-shaped hull that we showed earlier, but what we actually try and do is use every single part of the vehicle as part of the protection system. So that's the floor, the seats, the seat support mounts. Everything in there can be designed to be part of the protection system if you think about it. And so our role is to take apart every aspect of that and make sure it's the best it can be.
And there might be the simple idea that, a thicker piece of armour is better, but it's not about that. It's about layers, it's about angles, it's all sorts of, and the actual alloy material that it is made up of as well.
That's right. So materials science is a really important area, materials engineering for people. So within my team, I have an aerospace engineering degree, and so do a number of other people that work in that team. But the other area where we have a lot of staff is in that materials science, materials engineering. So working together, we bring more that sort of mechanical engineering, physics focus, and they really understand the materials. So together, we can come up with the best solutions.
Okay. So hopefully that demo was really good in terms of giving you an idea. If you've got any further questions about how some of the physics work, obviously the two experts we've got with us. We'll go through a number of different questions. If you've got some specific questions as well, please ask them, and we'll do our best to get through all of them. Leon's saying we're giving a lot of plugs to a certain hardware chain that does serve a lot of sausages on a Saturday morning, but it's just so you can relate to I suppose where we get it from. It's a fairly generic materials and that anyone can get to. In terms of some of the questions, this one's here for you, Brian, from Ashley. With DUS, which is the Defence University Sponsorship, what is the earliest time you can apply for sponsorship, and when do you have to start your training?
So with the application, to meet the eligibility requirements, you need to have at least completed 6 months worth of university studies. But that doesn't stop you coming in and doing that first stage of the recruitment process, so your U session, in that first semester at university. You generally, depending on what service you join, so if you would join the Navy, you would go into a 2-week induction course. That's outside of the academic semester. Similar for Air Force, you would do a 1-week induction course, and Army, you would do a couple of days induction. But you don't start your military training, so your initial employment training, until you graduate from university. So we really do allow you to focus on those academic studies, give you the opportunities to do your work placement at the military bases. But your career starts once you graduate and you complete your initial employment training after graduation.
So you can go to the university of your choice.
Yep.
Be a student, chill back, take the. It's almost like a wage, isn't it? In terms of what you get.
Paid a salary. So there's a lot of misconceptions out there that with the Defence University sponsorship, we'd expect you to move to Canberra and study at the Australian Defence Force Academy. That's definitely not the case. So we want you to stay at your university of choice, whether it's University of Queensland, QUT or RMIT down in Melbourne, or any of the other universities that offer accredited engineering degrees in the fields we're looking to recruit for. But you're paid a generous salary as well whilst you're at university. And we also pay your tuition fees and provide textbook allowance. So it's removing all of those barriers you may have to become the best engineer you can be from your studies and provide you that guaranteed job on graduation.
And we're here talking about engineering degrees, and that is certainly part of the DUS, but it's not just engineering as well. There's some you can be Defence University sponsorship with medical degrees as well?
Yeah, definitely. So not only engineering, Defence University sponsorship covers medicine and other allied health such as nursing, psychology, physiotherapy. You just maybe want to have a chat to your local recruiting centre to see what medical degrees we're actually recruiting for in that point in time. So it's not just about engineering, it's covering off on all of those other fields that we can't train at the Australian Defence Force Academy as well.
Definitely a great opportunity to look at, and something to look at there. Another one here from Andrew Peters. What are some of the most important skills you learned during your time at RMC that you find are most useful for your daily tasks as an Army officer?
I think the communication skills, the time management skills, how to relate to people. But probably the most important thing you learn there is resilience. So overcoming those hard times where you're put under a lot of pressure. And that's probably going to be the biggest thing you take away, is developing that resilience and the ability to soldier on through those difficult times. But it's all about how you relate to people, how you can lead people within the organisation and get the best out of them. Because at times we do work in quite arduous and testing positions.
Okay. I'll switch over to Hugh. I've got an engineering question here from Zach. So he's talking about the V-shaped hull works effectively from projectiles targeting the vehicle from above, but that shape doesn't maximise the armour effectiveness from the sides on the horizontal axis. How do you optimise the armour for all directions?
It's a really good question, actually. So there's always trade-offs in any type of engineering design, and so as you're completely correct, the V-shaped hull is mostly suitable for things that are placed directly underneath it, in line with the V. And so what that means, I mentioned earlier that we use the whole system to provide protection. So what you need to do is to understand where your limitations are and to then build on your strengths in other areas of the vehicle design to make sure that there's no longer a weakness there.
So I think we were talking about it well. It is a total system. It's not just, you're trying to get the best sort of approach.
That's completely right. So whilst we have to break down each part to, analyse it and then come up with the best solution for that particular component of a vehicle, we need to make sure that the entire system and set of systems in the vehicle acts together to provide the best protection.
And the other one that I think that we were sort of talking about is it's not static. We may have solved the problem now, but then the threat level changes, and we need to go back and have a look at it again. Is that right, Brian?
Yeah, so threats always change in the tactical environment, and that's where the engineers and the scientists come in, is how can we mitigate those threats to our soldiers on the battlefield. So it's all about learning. It's learning about what the threats are, what the science behind those threats are, and then doing the analysis and integrating new designs into the equipment, obviously to focus on that key thing, which is safety and survivability.
Couple more questions. If you've got any more questions, keep them going through. We'll do our best to get through as many as we can. Lucy's got a question, and I'll put it to you, Hugh, about it's a bit more about passion. So, how did you get involved and start working here?
I guess I kind of fell into my particular role here. When I was at university, I studied aerospace engineering, and when I applied for jobs, I was really passionate about working in aerodynamics, and engines was what I applied for within Defence Science Technology Group. As it happened, I got offered a position in the Armour protection group, and so it really started from there. I didn't even know the job existed, but since I've started working in the role, I think working with ADF members and basically seeing the impact your work can have on day-to-day lives of people, that's been really rewarding, I think, and where I really draw a lot of passion is the idea that I can potentially come up with a design and that can then be implemented into a vehicle. And there aren't that many jobs where you always get to carry through that concept to practical implementation.
And I suppose you're there making things safer, and some of your work is the first of its type in the world as well. Yeah,
so the fluid container stuff I mentioned, using water for protection, the level of detail we've gone into for armoured vehicle protection using that technology is definitely novel, and it's world leading at the moment. So places like this, and within the ADF, you really get the opportunity to work on really exciting technologies and being part of bringing them into service, not just kind of using something that's been there for 25 years.
Okay. Brian, a question here from Alyssa. How many female engineers are there in the Defence Force? Hard to answer because you probably won't know them all.
Yeah, that is a really hard question to answer. I know the figures for the female engineering population in Australia. So Engineers Australia reports about 10 to 15% of graduate engineers are females. So it's a great opportunity. We're missing a great asset, and we definitely want to get more females into engineering, not just in the Australian Defence Force, but into the wider community as well. So it appears to be a very male-dominated industry. if you have that passion for solving problems, working with people, definitely look at it as a career pathway.
And the other one is, we've focused a lot on that really pointy end of science and engineering, but there's lots of other, I suppose, practical roles that don't require a degree in the Australian Defence Force.
Yeah, definitely. So whilst we've talked a lot about the engineering, so that tertiary qualified engineer, we do have a lot of opportunities for the trades as well. So doing that hands-on maintenance work, actually making our vision come to fruition, because I can't run a lathe, I can't weld. We need skilled tradesmen to do that. But again, those fundamental inputs are still going to be the sciences and putting them into practice as well. So we're one of the few organisations that will take someone who is unskilled with a Year 10 or Year 12 education and provide that level of training so they can become a competent and efficient tradesman for us and really do that hands-on work, whereas the engineers are going to be doing more of that design and management in the background.
And that probably leads into a comment here from Rowan, sort of saying that there's no real good jobs like this for diggers or for enlisted soldiers. And I guess one of the real benefits of the Australian Defence Force is the training that is offered, not just to degree qualified through ADFA and DUS, but all the other qualifications. Probably, could you talk a bit about that, Brian?
So you're talking about the technical qualifications?
Technical qualifications,
so
exactly.
A lot of the trade qualifications are certified to a civilian equivalency, and they're going to vary depending on what service you do. So there are a lot of opportunities for people who are coming in via the general entry pathway to pick up a really good skill set that will not only set them up for success in the military, but also give them options for when they do choose to leave the Defence Force.
Yeah. The Defence Force is modernising. There's a lot more focus on IT and intelligence sort of roles. They need systems to run, and you can join up. We can train you and give you those skills to help with the Defence Force. But then you can also use them should you decide to leave at a later stage as well. So that sort of training element to the Australian Defence Force is a really important part. We will pay you to learn, and we will teach you.
It's exciting. And one of the new initiatives we have is Defence Technical Scholarship. It's been around for probably over 12 months now, and it's a way to encourage people to look at those more technical careers, whether it's in the trade, it's in engineering, or even some of the healthcare roles. It's generally activated if you do come through the recruiting process. You are applying for those, I'm not going to say STEM, but those technical roles that do focus on the science and engineering. And if you are successful at your U session, that's where your application for the Defence Technical Scholarship starts.
Got any further questions? We might have sparked a few thought-provoking bits of information. Let us know. We'll keep going through a few more questions. Mary Robinson asks, when are the next open days to find out more specific information about individual fields? That's there's information sessions all over the country every other week. If you go to our Facebook page and you click on the events, you'll actually be able to see them all listed out, and you can go along and ask questions there. There's also open days that occur, but anything that does come up, you'll see it on our Facebook page or on Defence Jobs under the Events tab. So hopefully that helps, Mary. By all means, come along, ask questions. You can meet people like Brian and ask him all the questions and get as much information as you can. What else do we have here? I think a question here from Zach. As an engineer, do you look at nature to understand how Mother Nature optimises armour, e.g. the turtle shell, to develop armoured vehicles?
It's an interesting theory, and it's one that I'm not sure if you're currently in a university research group, but there are a number of university researchers that have been taking inspiration from nature for armour systems. So a lot of that work is what we call long-range research. So it's looking at new material development to see whether we can take that kind of turtle shell concept. So basically looking at the structure as well as the material properties, linking them together into a new structure, and that gives you a better level of protection. So that work's ongoing. I'm not sure if we'll see that on vehicles, but if it is, it's probably 10, 15 years away, but there is work going on at the moment.
And I guess there's always work going on in terms of there's always a better way and something new and different.
That's right. So we're always looking for better materials, better ideas from protection. And I think the one thing to point out is that good ideas can come from anyone. You know, we're always on the lookout for, you know, some concept someone comes out with. They don't have to, you know, have a PhD in science or engineering. What we want to see is, you know, someone that's thought about the problem, puts up a proposal, and then we might see if we can go and evaluate it.
Okay. Zach's in year 12, by the way, so he's already thinking well in advance.
You know, he may be a future professor or working in our research group. We never know.
Scott's got a question here. What's the difference between aeronautical engineering and technology? So I think that's aeronautical engineering and aeronautical technology.
I think the question there is the difference between the Bachelor of Technology Aeronautical Engineering and the Aeronautical Engineering degree. So the Bachelor of Technology is the first 3 years of a 4-year engineering degree, whereas the aeronautical is that 4-year degree. So you don't quite pick up that full professional certification on graduation.
Okay.
It's a good opportunity for people who want to be pilots or air combat officers, to learn about the systems they're going to be flying and how to maintain them, but they have the opportunity to go back and potentially reskill later in their career if they're looking for a service change or a skill change or an upskilling themselves.
A few more questions. We'll keep them rolling in. We've still got time. Griffin asked a question that I've seen plenty of times before. What role does a combat engineer play in the Defence Force? And I suppose defining what a combat engineer is versus a mechanical engineer or an electrical engineer.
Yeah, so combat engineer, I think you're looking at those soldiers who are doing those route clearance activities, those expedient bridging activities. So they're providing battlefield clearance. They're providing counter mobility tasks. So they're out there doing those hands-on roles. That can be at the soldier level, or as a combat engineering officer, you're looking at certifying and designing bridges and coming up with tactical obstacles as well. Whereas the mechanical engineers, your electrical and aeronautical, you're looking more at that maintenance and design space of the equipment that we utilise.
So a couple of different roles. Combat engineer, I think the requirements are year 10, and you also need that practical mindset. And then as we go into combat engineering officer, that's when you're looking at, you know, you're required to have that year 12 and sometimes tertiary qualifications. So lots of different sort of roles in that space, depending on, I suppose, your level of education and experience and where you're at there. Some more questions. Jordan Coates asked, what's involved in getting into the mechanical engineering side of it? Applying, having a passion?
Yeah, definitely. So having a passion for science is definitely that first step. And if you're still in high school, I do recommend you look at the Australian Defence Force Academy. Obviously, mechanical engineering, like all of the degrees down at ADFA, physics and mathematics are going to be critical. So lodging that application when you're in year 11 to go to the Australian Defence Force Academy. If you miss out, you're graduating at the end of this year, maybe look at starting a mechanical engineering degree at another university and applying for Defence University sponsorship in your first year.
Okay. We'll keep going with the questions as they keep coming through. Sorry, just lost this. This one's an interesting one, Cody. What are some of the revolutionary engineering developments created by the Army? And we could probably broaden that out to the Australian Defence Force. And I can understand that's probably pretty subjective as well, but what are some of the I suppose, the breakthrough things?
I think, certainly from DST Group, the biggest one a lot of people know about is the over-the-horizon radar technology. So Australia's world leading in the ability to be able to sense. Basically, we have a large area of borders that we need to protect from the sea, and so understanding what's out there using that kind of radar technology that was developed here was really big. The other one that DST Group is often acknowledged for is the creation of the black box flight recorder that is on every airplane you fly in today.
There's some pretty big ones, and I guess even I think the Bushmaster, which, you know, granted we weren't involved with it directly, but that was quite a revolutionary design that seems to have been quite a legacy as well.
I'd say the Bushmasters certainly served the Australian Defence Force fantastically over the journey. It's probably not technology that is, unique to and having been developed in Australia. It's more something that we've taken on board and used, but people within the Defence Force have really worked hard over the last 10 years to improve the original design of that vehicle to make it continue its relevance in operations.
Okay, good question. Brody Landals, do you require an ATAR to become an officer in the Defence Force?
Depending if you want to start your career at the Australian Defence Force Academy, you definitely need an ATAR to gain entry to University of New South Wales. However, if you have that Year 12 education, those passes in the Year 12 English and 3 other tertiary entry subjects, you can apply to become a direct entry officer. So go to join the Air Force, Navy or the Army. So not necessarily an ATAR, there are a lot of options there for you if you don't have that ATAR. It just opens up more opportunities for you in terms of training.
Okay. Ask the questions. We're here to help. So I will do my best to get through all of them. There's a few questions here about medical conditions and whether there's anxiety and autism. Difficult for us to answer those questions. Engineers, social media guy, not medical professionals or doctors. That's something that you're going to have to ask, or you're going to have to start an application, go in and talk to the people at the Defence Force there who will actually assess you as an individual, not just as a generic number. So medical questions are really hard for us to answer. It's a case-by-case basis. Kim Bannon says, happy Science Week. We agree. I hope you really enjoyed it. So I think we're now starting to run out of time. Are there much scope for other types of sciences in the ADF? I'm obtaining a PhD in neuroscience. So I think there's roles if you've got that neuroscience structure. I'm not sure about that one.
It's a tricky one. Obviously, we don't do a lot of research in neuroscience, but if you have a passion for solving problems, maybe you can take some of those skills that you've developed through your PhD and mould them into a leadership and management role within the Defence Force. So looking at those neuroscience competencies and maybe doing a bit of a career change, getting less out of the research and more into some hands-on leadership roles.
Cool. Well, that just about finishes it for today. Like all of us here at DST, as part of National Science Week, we really want to thank you for tuning in. Thank you for your questions. Thank you for participation. I hope you learned something. I certainly did. And by all means, if you've got any further questions, just ask us. And there are an enormous range of science and engineering career opportunities in the Australian Defence Force, either degree qualified or non-degree qualified. So there's lots and lots of things available. So check it out and you know where to find us. So thanks for joining us today and we'll see you next time.